up, my chemistry students? Mrs. Thompson here, and today we're working on the second part of pH calculation now. You should refer to the chart that I told you about last time, which looks just like this. So I'll keep referring to this chart. Alright, so here's our first example. It says, what is the pH of a solution with a hydrogen ion concentration of 4.2 times 10 to the negative 5? So here we're going to look at some examples where the coefficient in front is not a 1. And so we need to do that because we're going to have to use this calculator here. Okay. So let's do that. So what is it? Where are we going to start? So we want a pH and we have a hydrogen ion concentration. A hydrogen ion concentration, well, that's H plus. Concentration on the brackets, hydrogen ion, that's H plus. So that means that we have pH and H plus. This and this, so we have these two equations. We want to use the one that solves for the one that we're looking for, where this is the pH. So that means we need pH equals, so that one would be this negative log of H plus. Alright, so let's plug that in. pH is equal to the negative log of the H plus concentration, and it's 4.2 times 10 to the negative 5 mole. Alright, so let's
plug that into the calculator. That's negative log of 4.2 second E for my calculator. That's times 10 to the power of. It takes care of all of that. So you don't put times 10 to the power of, you just put E, negative 5, and then hit enter. Now, in the past we were able to just say, okay, well, the coefficient in front is a 1, so we could just look at the exponent. Well, it's going to be close to what the exponent is. This is just going to change it by a little bit. This is actually bringing it down. So normally we'd just say it's 5. Well, it's somewhat close to 5. It's 4.38. So we're going to go ahead and write that down. So we'll round to actually 2 significant figures. So that's going to be 4.4. And that's my answer. All right. Next one says calculate the hydroxide ion concentration of a solution with a hydrogen ion concentration of 1.9 times 10 to the minus 6. So here is my chart. Okay, so we want hydroxide ion concentration, which is here, and we have a hydrogen ion concentration, which is here. So that's a one-step problem right there and there. So we need a calculation that has that in it. So here and here, that's this one. So I'm going to write that down. Kind of hard to see, but there it is. Okay, well, I want to solve for the hydroxide ion concentration. That is the OH minus. That's the hydroxide ion concentration. Okay, and so that means I'm going to solve for that one, so let's divide both sides by the hydrogen ion concentration. So that cancels. And so that's just going to be the hydroxide ion concentration is equal to 1.0 times 10 to the negative 14 divided by this number, 1.9 times 10 to the 6. Now before we could just look at it and say, okay, that divided by that, but now we have to do this and this. So let's just put it in the calculator. All right, so that would be, I would use the E button, 1.0 second E. Now, when I do the E button, that takes care of keeping it together. So if you don't use the E button, then I recommend that you use parentheses. So that divided by 1.9 e to the negative 6. So divided by that. And I get, ooh, I get this. Okay, this is a good moment here because what I'm looking at here is something where I can't tell something to two significant figures. All I can tell is one significant figure. So what I recommend that you do is you actually tell your calculator, go ahead and put this into scientific notation for me. So to do that, you go second, and then above DRG is sci/engineering. So that's why I put second. So you put, instead of flow, you put sci and hit enter. And so it says it's 5.26 times 10 to the negative 9. Don't forget this part right here. That if you leave that out, you'll get that completely wrong. So it's 5. Well, we want two significant figures, so that's going to be 5.3 times 10 to the negative 0.9, so 9. And then really that's the molarity of that. So we're going to put N. And that's my answer for that one. All right, so here I've just been giving you the concentrations of things. And so things don't actually really come in concentrations. What they do come in is actual formulas. So, concentrations of ions. So something like this. Find the pH of 0.010 molar HCl. Okay. So what we have to do with that actually is kind of have to figure out what is HCl going to give up. Is it going to give up hydrogen ions? Is it going to give up hydroxide ions? Well, HCl starts with a hydrogen, so that means it's an acid. Acids are hydrogen ion donors. So let's see what that dissociates into. So HCl is going to break up into hydrogen and chlorine. So that means that for every one HCl, I will get one H plus and one Cl minus. Okay, so that means that if the HCl is 0.1010, well, that's a 1-to-1 ratio. So if this is 0.010, then H plus is 0.010. Okay, that just transferred over. All right, so then let's find the pH of something that has an H plus concentration of 0.10. We know how to do that. Why do we know how to do that? Because pH is negative log of H plus, and we now have H plus. Okay, so pH is negative log of H plus. So that means 0.010. All right, excuse my dog. All right, so we could change that into scientific notation and just use that, but we can plug that in too. So negative log of 0.010 is 2. Oh, mine is in scientific notation still. Let me show you how to dig that up. So you go second, psi. Instead of psi, you make it into flow. Hit enter. So that's just 2. So that equals 2. Do I want to leave it as 2? I don't know how many sig figs does that have. That has 2 sig figs, so that's going to be 2.0. All right. Next question. Find the pH of 0.10 molar H2SO4. Is that an acid or is that a base? Well, it starts with hydrogen, so it's an acid. The other thing I didn't tell you, these are strong acids. We talked about strong acids last time. Strong acids dissociate 100%. Since they dissociate 100%, that means all of it breaks up. That's why this turns completely 100% into that. If it were a weak acid, we'd have more calculations to do. And thankfully, at this level, we don't have to do that. So 100% of it turns into that. Okay. Here's another strong acid. Okay. Certain concentrations, not so much, but for our level, we're going to deal with it as a strong acid. So that's also strong. All right, which means that H2SO4 is going to break up into, so it's going to dissociate. Well, how many hydrogen ions does this one have to donate? it has H2. So how many hydrogens? That's 2. And a sulfate. So if this is 0.010, and for every one of these I get 2 of those, then this is going to double. So from here to here, this is going to be 0.020. This doubles. Why? Because of that coefficient. This is a 1:2 ratio. Okay. All right, so then what are we going to do? Well, we want the pH, and we have the concentration of this H+. It's 0.020. So pH is the negative log of 0.020. All right, so let's plug that in. Negative log of 0.020, and that's 1.6989. So then we need 2 significant figures, so that's 1.7. Equals 1.7. All right, next one. Calculate the pH of 0.05 molar CaOH2. Well, this is a strong base. How do I know it's a base? Well, it has a hydroxide ion in it. So this is strong base. Okay, what do strong bases break up into? Well, they don't break up into hydrogen ions and whatever else. They break up into this plus hydroxide ions. So let's do that. CaOH2. So it's going to break up into the metal. This is calcium. Calcium's a 2+. Okay, plus hydroxide. Well, how many hydroxides are in this formula? There are 2. So it's going to be 2. All right, so if this is 0.05 molar, then we want hydroxide because we want the POH and pH, and we're going to have to do some calculations here. We want to get to here. Well, that's going to double to get to there because of that coefficient. So that's going to be 0.10 because that times 2 is 10. All right, so then what can I find? I have OH this time. I can't find pH from OH. So what I can find is POH. So POH is the negative log of the OH minus. So let's plug that in. That's the negative log of 0.10. So negative log of 0.10, which is 1, because this is actually negative log of 1 times 10 to the negative 1. That's 1.0. And then I want to find pH. Well, I know, let's go back to this. I've got the POH. To go from POH to pH, I know that pH plus POH is 14. So I can take 14 and I can subtract that 1.0, and I'll get that the pH is 13. Okay, last one. Calculate the hydroxide ion concentration if the pH is 4.86. Alright, so then we don't have an equation to deal with, strong acid or strong base. We just have to look at this. We have a pH of 4.86. So, and we want hydroxide ion concentration. Oh, that's OH minus. That's what we're trying to find. Okay, so we want this and we have this. So here and here. So we could go up and over, or we could go across and up. Remember I said going through here is easier, so we're going to go this way and this way. So to go from OH to POH, OH and POH, that's these two. We want the one that solves for POH. So that's negative log of OH. No, we want, I'm sorry, we have this one and we want to get to this one. So we're going to go down and over. So pH to POH. That happens. Sometimes we make mistakes, so we gotta fix that. So pH to POH. So pH plus POH is 14. So that means that 4.86 plus POH equals 14. Alright, so if that's true, then POH is equal to 14 minus 4.86. And that's 9.14. Okay, now we want OH minus. So OH minus, from here to here, we need one that solves for OH minus. So that's going to be 10 to the minus POH. So 10 to the minus POH is going to be 10 to the minus 9.14. We cannot leave it like this. So if you thought we could leave it like this, sorry, we can't. We actually have to plug that in. Before we could because the base was 1 and we had even numbers here, but we can't when we have decimals here. So 10, we just put the caret, it's easy. 10 to the negative 9.14. That's what I wrote, yep. And then you have to hit enter. And so what that does is it gives me a number close to 9, but not quite 9. And as far as the exponent goes. So that works out to be 7.3624 times 10 to the, looks in the corner, it's a negative 10. And then we box that answer. Alright, so we have to learn to work this calculator. Let me know how you're doing.